Hello everyone and welcome back to Diksha Karnataka YouTube channel, and currently we are discussing all the important chapters for your midterm. If you are currently studying in second PU of Karnataka board, then your midterm is very near and maybe it's already started. But if you want to revise all the chapters quickly, all the important chapters quickly, then you must go through all the lectures that we are doing on our channel, all the subjects included. So today I am here to discuss two chapters of physics. Which two chapters we are going to discuss? We will be discussing electromagnetic induction and alternating current. Both the chapters are important in their own way. Okay, they have weightage of 7 and 10 marks from the chapters. We will see all the details from these two chapters. First, we will start with electromagnetic induction, and we will also see the marks distribution for this chapter. So what is the mark distribution for the chapter? First of all, out of the three blueprints, two blueprints are saying that there will be two MCQ questions from this chapter. So basically two MCQ questions. If you are prepared enough, if you are ready enough, you can score easy 2 marks, okay, without too much difficulty. Okay, and one of the blueprint is saying there will be a fill in the blanks as well. Fill in the blanks MCQs are our sometimes it can be a pain, sometimes it is easy to answer. So be careful when you are answering, read the questions carefully, and one of these questions will be definitely a HOTS question. HOTS question means slightly difficult question. Okay, so one of such questions will be slightly difficult HOTS question, and more importantly, there will be no 5-mark questions from this chapter, only small answer type questions, one 2 marks question and one small answer type question, 3-mark question. Okay, and out of these 2 questions, one of them will be a numerical problem. Okay, there may be a numerical problem from 3-mark questions, one numerical question from 2-mark question as well, possibly. Okay, so there is a chance that one of these 2 questions will be a small numerical questions. What is the advantage of the small numerical question? You just need to remember the formula, remember the concept, apply the formula directly, you can get the answer. Very easy, very small questions. Okay, so you don't have to put your too much head, too much effort. If you answer them correctly, full marks you can get, right? So let's start with the MCQ first. The energy stored in an inductor of inductance L in establishing the current I in it. So what is the energy stored? We know that energy stored in an inductor is given by half Li square. Okay, always there is a factor of half. If you remember, capacitance also half CV square. Okay, in case of inductor it is half Li square. So correct answer is option D. Simple, right? You have to be careful that there is a square term, there is a half term. Okay, both of them should be here. So here they have other options are Li square and Li, definitely not possible. Half is there but no square is there, so you can ignore this term as well. So you have to be careful. There will be a half, there will be a square. Sometimes they will try to confuse you by adding something V square, LV square. So be careful about those options as well, but it will be half Li square. If you have studied, if you remembered it, you can get full marks from this. Now this is a little bit difficult hot question, so higher order thinking skill question. The following are the statements related to self-inductance. Okay, what are the statements? First statement says that the self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. Okay, we know that self-inductance for a coil is basically proportional to mu naught A. There are other terms involved, okay, which are basically constant, but obviously mu naught is permeability, okay, and A is area. So area means geometry. Okay, it depends on the geometry, how if it is a coil, if it is a rectangle, what is the shape of that coil depends on that. And second statement, let's see. So this is a correct statement. Okay, so this statement is correct statement. Now next, say statement number 2, the self-inductance is a measure of electrical inertia and opposes the change in the current in the coil. Okay, so the statement looks difficult, but you have to remember that yes, self-inductance opposes the flow of current through it, and that is why it is called electrical inertia. Okay, so this is the main thing that is happening, and this is the reason. Okay, electrical inertia, that is why it is called electrical inertia. So option 2 is also correct. Okay, both of the statement is correct. So let's see what are the options. Both statements are wrong. No, only statement 1 is correct. That is also not fully correct. Both statements are correct. Yes, both statements are correct. So option C is the correct answer. Okay, this is not reason and assertion based question, so relatively easier compared to reason and assertion, even though reason and assertion sometimes they may be a little bit difficult because you have to be careful whether actually assertion and reason are linked or not. Okay, so that is the main thing. In this case there is no link directly, but both statements are correct, so definitely option C is correct. Now let's move on to the question number 3. This is also a little difficult question. The direction of current induced in the loop ABC shown in the figure is. So here we have a loop ABC. Okay, and they have asked you to find the direction of current in some cases. Let us first find what is the direction of magnetic field due to this given current I. Okay, the direction of magnetic field, as I said during my other lectures, KCET lectures, that if the current is flowing in this direction, how can you find the direction of magnetic field? You have to bend your fingers. You have to bend your fingers and your fingers will point towards the direction of magnetic field. So in this case, as you can see, if you put your fingers, if your thumb in the direction of current, okay, then your fingers are pointing into the page. Right, so your fingers are pointing into the page. So all the magnetic field at this point is into the page. Okay, so magnetic field is into the page where the loop is there. Now let's see the option A. Here you have to justify or check all the options one by one. Along ABC, if I is increasing. So what is happening if I is increasing in this direction? Okay, so what will happen? The magnetic field into the page will be increasing. So magnetic field into the page will be increasing. That means whatever induced current in the coil, that should oppose it. If the magnetic field is increasing, then the induced field will oppose it. So how it will oppose? It will oppose such that the induced magnetic field is in this direction, outside, out of the page, right? So induced EMF should be out of the page. So this is the induced EMF. Now induced EMF out of the page means how can we find the direction of magnetic field for a coil? For a coil we can find using our fingers again, but in this case our fingers will be along the loop and thumb will point towards the direction of magnetic field. It is now opposite. Okay, for a straight line, thumb points the current, finger gives you the direction of magnetic field. In case of coil, fingers gives the direction of current and thumb gives you the direction of magnetic field. So magnetic field, as we have decided, it will be out of the page. So current should be in this direction, that is ACB. Okay, current should be ACB, right? So this is a wrong statement. This statement is wrong. Okay, now along ACB, if it is decreasing. Now let us understand what is the meaning of this. If magnetic field is decreasing, okay, magnetic field is decreasing, that means into the page is decreasing. Okay, into the page is decreasing, so the magnetic field will be such that it increases the magnetic field into the page. So in that case, magnetic field will be in the direction of ABC. So this is also a wrong statement. Okay, so basically you can say that both are contradicting statements. Okay, ABC increasing, ACB decreasing, that if this is false, this should also be false. Okay, now let's see along ABC if I is decreasing. Now as I said, if the current magnetic I is decreasing, that means magnetic field is decreasing into the page, so the induced EMF will try to increase. Whatever is happening, induced EMF will try to oppose that, right? So induced EMF will oppose the induced EMF, so in that case it will be into the page, right, into the page along the same direction of magnetic field, because original magnetic field is decreasing, so the induced EMF will try to increase it. So in that case it will be into the page, so it will be ABC. So this is a correct statement. Okay, along ACB, if it is constant, in case of constant there is no induced current, so D is wrong answer, right? So we have found our correct answer. Correct answer is option C. Be careful for such questions. This might be little tricky, but not super difficult. Now let's see. Now it's an easy question. The polarity of induced EMF in a coil is given by induced EMF in a coil is given by Lenz's law. Okay, not Faraday's law. Faraday's law gives the magnitude, okay, and the direction or polarity is given by the Lenz's law. Okay. Now SI unit of magnetic flask is Weber. Okay, you have to be you have to remember this value. Okay, and Weber per meter square is nothing but magnetic field, which is Tesla. Okay, the Weber per meter square is equals to Tesla, that is magnetic field, and Weber is magnetic flask. Okay, you have to remember the Weber or WB. Sometimes only WB is written. So WB, if you are writing WB, then W will be capital. If you are writing Weber, then W will be small letter, because Weber is a name of a scientist, capital W. So generally when same thing goes for Newton, right? If you remember Newton, capital N is okay. If you are writing full Newton, then it will be small n, because capital N Newton is a name of a person. Now let's look into some fill in the blanks from this chapter. What are the fill in the blanks? The device which works on the principle of electromagnetic induction is dash. Okay, what is the device that works on the principle of electromagnetic induction? Let's see the option. Magnetic potential energy, it is not a device. Conservation of energy, it is also not a device. Inertia, not a device. AC generator, it is a device. Okay, allows, opposes, these two are also not a device. So just apply logic even if you don't know the answer. Okay, if you just apply some logic, then you can answer. Okay, so AC generator is the correct answer. Okay, AC generator is the correct answer. Lenz's law is based on, we have seen in the previous MCQ as well, it is basically based on the conservation of energy. So Lenz's law is based on conservation of energy. Okay, so we will see that in another question as well. So conservation of energy. Self-inductance plays the role of dash. First MCQ, remember, first MCQ or second MCQ where we discussed about self-inductance. Self-inductance is basically plays the role of inertia, electrical inertia or normal inertia. Okay, both are okay. Now, energy is stored in an inductor in the form of, what is the form of energy stored in a inductor? The energy stored in a form of inductor is half Li square, right? And this is nothing but potential energy. Always any device, capacitor or inductor, whenever they are storing energy, they are storing potential energy. Let's see the option. Magnetic potential energy, first one, magnetic potential energy. They have even specified what type of energy it is. Okay, so it is magnetic potential energy. Okay, I am writing in a shortcut so that I can move forward. Induced EMF always opposes any change in the magnetic flux. This one we know. This is the statement of the Lenz's law, modified statement of the Lenz's law, right? So induced EMF always opposes the changes in the magnetic flux. Okay, so we have found all 5 correct answers, so we have secured our 5 marks. So be careful while answering FIB. Okay, I have seen people are making 2-3 correct answers, but last 2 they are making random guesses. Don't guess. Okay, just see if it is making any sense. Once you start seeing 2-3 questions, if you are solving 3 questions correctly, then other 2 should automatically be corrected. Okay, even though the options may be little close, if you apply logic, then you can find the answer. Now let's see short answer type questions. Question number 1, give the principle of AC generator. Why is a current induced in an AC generator called a alternating current? Very simple answer. What is the principle of AC generator? An AC generator converts mechanical energy into electrical energy because by changing the flux linked with the rotating coil. So we know that there is a coil which is rotated in a magnetic field. Okay, so if you remember, diagram is not necessary here. Okay, if you draw, that is fine. North south here, there is a coil here. Okay, so as this coil rotates around its axis, okay, the flask linked with the coil changes, and because of that change in the flask, there is an induced EMF, and that induced EMF is basically because of the conversion of mechanical energy into electrical energy. Okay, that is the basic thing. This is the main source of our every day-to-day need. Okay, so the electrical energy that is used in our homes to light up, to switch on the fan, to switch on the AC, to watch the TV, to watch your mobile phone, that from where you are currently watching, everything is powered by AC current, and AC generator supplies it. Okay, now why it is called AC? Because the direction of current produced in an AC generator changes periodically, and therefore the current is called alternating current. Okay, so the direction of, very simple logical answer, even if you have not studied this chapter, you can answer at least this question. Okay, so because the direction of current changes periodically, that's why alternating means changing, right? So alternating means after every certain period it changes its direction, that's why it is called alternating current or AC. Okay, now next question. State Faraday's law, another easy question. Faraday's law and Lenz's law of electromagnetic induction. This is also very popular question. Okay, Faraday's law, the time rate of change of magnetic flux through a circuit induces EMF in it. Now this is a 2 mark question, so the expression is not required. You can anyway write that. Okay, it is proportional to d phi by dt. Okay, after this you can write epsilon is equal to minus d phi by dt. This negative sign actually comes from Lenz's law, not from Faraday's law. Okay, Faraday's law only says that it is proportional to d phi by dt. Okay, or magnitude wise, magnitude is equals to d phi by dt, but Lenz's law gives the negative sign. Okay, so the time rate of changing of magnetic flux through a circuit induces EMF in it. Okay, what is Lenz's law? Lenz's law is the polarity of induced EMF is such that it tends to produce a current which opposes the change in the magnetic flux that produces it. Okay, so the current that being produced, if it is a closed loop, obviously there will be not only EMF, there will be a current as well, and that current will oppose the cause, that is whichever is causing it, right? So it is always the duty of conservation of energy, that energy cannot be created or destroyed. Here, if this is not true, then we could have created energy, but that is not possible, right? Because Lenz's law prohibits it. Now, a boy pedals a stationary bicycle. The pedals of the bicycle are attached to a coil of 100 turns. Okay, this is a numerical question, small numerical question. Even though the question text is very big, trust me, this is a very small numerical question. Each turn of the area 0.2 meter square. The coil rotates at 6 rotations per second, and it is placed in a uniform magnetic field of 0.01 Tesla, perpendicular to the axis of rotation of the coil. Calculate the maximum value of EMF generated in the coil. Now this is basically an AC generator. Okay, the entire text that they are describing is an AC generator, and we know that the maximum EMF generated in an AC generator is NBA omega. This is the formula. One formula that you have to remember for AC generator, NBA omega. Those who are preparing for JEE or NEET or for KCET, they should have, I guess they have already remembered this formula. Okay, now what is N? N is 100. Magnetic field B is given here as 0.01. What is A? A is given 0.2. 0.20 is 2. Now what is omega? Omega is angular velocity. Now here it is given 6 rotation per second, that is RPS. Okay, 6 rotation per second means in one rotation how much angle it rotates. In one rotation the total angle is 2 pi. You should remember that. In one rotation total angle is 2 pi. So in 6 rotation the angle should be 6 times 2 pi. Right, that is 12 pi. This is the omega. So omega is 12 pi. Okay, now let's calculate what is the value. So 100 times 0.1, this is simply 1, right? 0.01 is 1 by 100, 100 is 100, so 100 cancel. Now what is the value of this? 0.2 times 12, that is 2.4 pi. Okay, you can leave your answer here, but you have to add the unit. You can leave your answer here, or you can use the calculator to find the value of pi and calculate whatever 7 point something the answer will come, 7.54. So answer will be 7.54 volt. So calculation is at least this much is required. Okay, after that if you have the calculator, because calculator is allowed, you can calculate it and you can find the answer. Okay, simple question, only one formula that you have to remember. All the values are given. 100 turns is number of turns, that is N. Okay, capital N represents number of turns, B is magnetic field, A is area, omega is angular speed. So angular speed only you have to convert, and rest of the problems are easy. Okay, I guess you have understood this problem. Now let's move on. Now this is a small now 3 marks questions. We are into 3 marks question territories. Okay, derive an expression, okay, for motional EMF induced in a straight conductor moving perpendicular to the uniform magnetic field. Very interesting question. Okay, it is a very common question. I will just do the mathematics for this. You have to write a little bit, describe this diagram a small amount. Okay, once you have described this diagram, that there is a coil, okay, there is a frame where PQRS and PQ is moving in the direction in the negative x direction, okay, and the distance at some instant the distance is x, the length of the coil is L, okay, length of the frame is L. Then you can write that what is the flask, total flask in this area. What is the total flask in this area? Now you have to remember the steps. How can you derive it? What is the total flask? Flask is basically, how we know, flask is B times A, area into magnetic field, that is flask. Now what is the area of this? This is a rectangle. So what is the area of a rectangle? Length into breadth. Length is L, breadth is X. So area is, so we can write this as BLX. Okay, so now from law of electromagnetic induction, combining Faraday's law and Lenz's law, we know that induced EMF is given by minus d phi by dx. Okay, so minus d phi by dx. So what you have to do, you have to differentiate it. Now B and L are constant, so it will come out, it is not x, sorry, it is t. Right? So it will be minus B and L are constant, so B and L will come out. X is changing because as you are moving in this direction, x is changing. The value of x will be different when this reaches here, right? So x is changing. So this is dx by dt. Now what is dx by dt? If you remember slightly from your first PU, dx by dt is nothing but instantaneous speed. Okay, so here dx by dt is nothing but instantaneous speed, but here what we will do, because x is decreasing, if it is moving in this direction, x is decreasing, so what we will do, we will use this as v, and we will write that here V equals to minus dx by dt. You don't need to explain why it is minus, but you have to remember that V will be minus dx by dt. Okay, so BLV, or sometimes it is called BVL, whatever way you are comfortable with. Okay, this formula is also important for numerical questions. Okay, this formula important for derivation, this formula important for small 3 marks numerical questions as well. Okay, we will see that in a while. Okay, so very easy derivation. Okay, only thing that what steps you have to remember what is phi is, magnetic flask, then you have to recall the formula for induced EMF. Once you have done reached this state, then you have to remember V is equal to minus dx by dt. That's it. Everything else is the steps, right? Now let's move on to the next question. This one I will not explain, I will just give you the diagram. This is very simple question. Describe an experiment to demonstrate the phenomenon of electromagnetic induction using a bar, magnet and coil. To answer this question, this diagram is compulsory. Okay, especially it does not matter how many coils you are drawing here, the coil must be connected to a galvanometer. This is very important. I will tell you what are all important. Okay, the magnetic field is going in this direction, and there should be an arrow on the magnet so that it explains either you can add one arrow in this direction or in this direction, does not matter. Okay, and while explaining you have to explain 2 steps. When the magnet moves towards the coil, the galvanometer deflects, and as you are taking the magnet away from the coil, the galvanometer deflects in the opposite direction. That's it. These 2 points should be mentioned clearly. As you are moving the magnet towards the coil, the galvanometer shows a deflection, and as you are taking the magnet away from the coil, the galvanometer shows a deflection in the opposite direction. This opposite direction is important. Okay, since the orientation of the coil, the magnetic field is not clear how the magnet is oriented, so you cannot exactly predict how the galvanometer will deflect for the first case, but for the second case it will be definitely in the opposite direction to that of the first case, right? So as soon as, also you have to mention, as soon as the magnet is stopped, the galvanometer stops showing any deflection. So when the magnetic flask linked with the coil is not changing, there is no change in the no induced EMF, right? So these 3 things you have to mention. Diagram, these 3 points, at least 2 points you have to mention along with the diagram. If you can write the 3rd point, that when you stop the magnet there is no induced EMF, so galvanometer stops showing deflection, that is also fine. Okay, so very simple question. I hope you have all studied this expression, you have studied everything, right? Now next question, this is a small 3 mark question, also based on the formula that we just derived, that magnetic induced EMF is BVL, based on the same formula. A horizontal straight wire of length 10 meter long is falling with the speed of 5 meter per second at right angles to a magnetic field 0.30 times 10 to the power of minus 4 Tesla. Find the instantaneous value of the EMF induced in the wire. So instantaneous EMF induced in the wire is given by BV. If this question comes, you are very lucky. Simple formula, every value is given, you put, you get 3 marks. Nothing to worry about, okay? But formula, you have to write the formula. For writing the formula, there is 1 mark, okay? So write the formula. B is given, B is 0.3 times 10 to the power of minus 4, V is given 5, okay, L is given 10 meters, okay. So just use the value. If this question comes, you are very, very lucky. So now if you see 0.3 times 10 is 3, 3 times 5 times 10 to the power of minus 4, that is 15 times 10 to the power of minus 4. Now it is a induced EMF, so EMF is unit is volts, so you have to use the unit as well. So you have to write the unit, you have to write the formula, and then calculation. Okay, 3 marks, full 3 marks. Okay, so correct answer is 15 times 10 to the power of minus 4 volt. Okay, this concludes this chapter, electromagnetic induction. Very simple small chapter. I hope you will be able to answer all the questions from this chapter. Now let's move on to the next chapter, that is alternating current. Okay, we will now discuss alternating current, and by love we call this chapter AC. Okay, so we will see what is the mark distribution for this chapter. Again 7 marks from this chapter, but interestingly from this chapter 1 MCQ and 1 fill in the blanks. Okay, it is coming in everything and it is a remembering based, so this will be easy questions, and there is no short answer type, there is no 2 marks, there is no 3 marks question, only one question large answer type, and it is definitely a numerical question. Okay, and I will show you, if you practice a few different patterns, then there is a high chance you can score 5 marks from this chapter alone. Okay, so this is a very recommended chapter for numerical questions. Okay, even though the level of questions in your previous year paper is little higher, but if you remember the formulas are fixed. Okay, you are having the access of calculators, so there is no trouble of calculating difficult values as well. Only 3-4 different formulas, easy formulas you need to remember, and you can solve all the numericals. So that is the one chapter I recommend to my students for numerical problems. Okay, now let's move on. Let's see the 1 mark MCQ questions. An ideal step up transformer decreases. Okay, ideal step up transformer. So first of all, what is a step up transformer? Step up transformer is something which is if you input 1 volt, you will get more than 1 volt. Say for example, if you input 1 volt, you are getting output as 10 volts. Okay, so step up transformer means which increases the voltage, right? Now if voltage is increasing, that means current has to decrease. Okay, in an ideal transformer power is same. Okay, so power does not change, frequency does not change, only thing that changes is voltage and current. Okay, if voltage is increasing, current will decrease, if voltage is decreasing, current will increase. This is the simple logic, simple thing. So if voltage is increasing, current will decrease. Okay, so step up means voltage increasing, so you have to remember the meaning of the terms. Okay, step up means voltage increasing. Okay, so current will decrease. Now next question. In a transformer, NP and so if you see in your model question papers, okay, and previous question papers, most questions are on MCQ section are based on transformers. So transformers are super important, and likely your annual exam also, in your midterm exam also, there will be a question from transformer on MCQ question. As you can see, there are nothing to do in case of 2 marks 3 marks question. So 2 marks 3 marks question, nothing is coming, and in the numerical question anyway you have to answer based on LCR relations, right? So all the transformer related questions there is a high chance it will be asked in the MCQ section only. In a transformer, NP, N primary and N secondary are the number of turns present in its primary and secondary coils respectively. The transformer is said to be a step up transformer if. So NP is the number of turns in primary, NS is number of turns in secondary. Step up transformer, what is the step up transformer? Step up transformer means where your output voltage is higher than input. So output voltage is higher than input, that means output is linked with secondary. So number of turns in the secondary has to be higher than primary. Okay, step up means number of turns in the output has to be higher than number of turns in the primary, right? So NP must be less than NS. Okay, simple question, simple answer. Even if you don't remember, okay, step up, step down, you don't need to recall everything, you don't need to mug everything out. Okay, you can use simple logic, you can use little bit concept, and you can answer. Okay, that is what my suggestion is. Now let's see. In a transformer, the windings of another transformer based question. In a transformer, the windings of primary and secondary coils are wound one over another to reduce the energy loss due to. So if you see, there is a transformer where primary, okay, and secondary both are wound in the same place. Okay, now this is because the flask linked, whatever flask is linked from the primary, the same amount of flask should pass through the secondary as well. So this is basically to reduce the flask loss. okay, flash leakage. Eddy current, we have not discussed eddy current. There is a different way of reducing eddy currents. Resistance of the windings you cannot change anyway. Hysteresis is not out of the syllabus only, so you don't need to think about hysteresis and eddy currents. Resistance of the windings does not make any sense. The only thing is flux leakage. Okay. Now, question number 4. In case of alternating voltage applied to a resistor, the current leads to the voltage by a phase angle of pi by 2. So, in case of alternating voltage applied to a resistor, alternating voltage applied to a resistor, they have asked different phase related questions. Alternating current applied to a resistor is same as DC current applied to a resistor, only the average value will be changing, but current and voltage will always be in phase. So, V equals to IR formula is still correct, okay, because voltage and current are in phase. So, phase difference is 0. Okay. So, current and voltage are in phase or phase difference 0, everything is correct, both options are correct, but here they have not given any phase difference 0. So, phase difference 0 or in phase. Okay. Simple. Now, question number 5, the average power dissipated in an AC circuit is maximum if the AC source is connected. So, basically as I said, the maximum AC current power dissipated is when it is connected to a resistor, pure resistor, okay, only to pure resistor. If you connect it to inductor or capacitor, power is pure capacitor and pure inductor, power dissipated is 0. In case of combination of capacitor and resistor, okay, the maximum power is not dissipated, some power, it is actually less than that, and for capacitor and inductor, obviously they don't have any power dissipated in it, so it will be 0. Now, let us see next question. Okay, now we are going to discuss fill in the blanks question, 5 fill in the blanks question. Fill in the blanks also coming from this chapter, so this is also important. Okay, all the blueprints has fill in the blanks from this chapter, so that's why fill in the blanks, one fill in the blanks is definitely going to come from this chapter. The principle of working of a transformer is, what is the principle of working of transformer? Let's see, phasor. Is it making sense? Principle of transformer is phasor? No, right? Wattless current, is it making any sense? No. Mutual induction, it is making a sense. Okay, principle of working of a transformer is based on mutual inductance. So, is based, actually there will be a based on, so mutual inductance. Make sure, read the options twice, read the question twice, and then you make sure if your answer is making any sense or not. The power factor of an AC circuit containing pure resistor. Okay, so power factor is 0. Power factor for pure resistor is 1. Okay, power factor for pure resistor is 1. Power factor for any other like inductor or capacitor, it is 0. Okay, you have to remember that. A rotating vector used to represent alternating quantities is called. So, the rotating vector which represents alternating vector is called a phasor. Okay, so it will be phasor. Okay, now one thing that I give you a tip here, that here we are doing all the 5 questions from the same chapter. When you are writing in your exam, all the 5 questions, for 5 fill in the blanks questions will be from different chapters. So, in that case you have to be little extra careful. Okay, so you have to be little extra careful. I will try to do a video where I will discuss all the important questions, some very concise questions from different chapters, so that you get a feel of your what may be your upcoming second PU question paper. Okay, there will be a 70-mark question paper only, along with some extra questions, so that you get a feel, okay, what type of questions may be coming. That is not a question paper obviously, but a type of question paper. Okay, the average power dissipated in an AC circuit is, so the average power dissipated in an AC circuit is when the source is connected to a pure capacitor. So, average power dissipated in a pure capacitor is 0. Okay, it is maximum for resistor, power factor is 1, power factor is 0, as well as power dissipated is 0 for pure capacitor, pure inductor. the current through an ideal inductor is called, the current through an ideal inductor is called wattless current. It does not consume any power, that's why it is called wattless current. Okay, even though current is passing through it, so but it is not consuming any power, that's why it is called wattless. Now, I am going to solve 3 to 4 questions from this chapter, numerical questions. So if you are faint hearted, don't worry, even if you have not studied this chapter completely, I will tell you how you can score some marks even if you are not able to solve the entire questions. If you write the correct formulas, if you insert the correct values, you will still get some part marks. Okay, so even if your final answer is incorrect, you will get full marks if you just write the correct formulas and insert the correct values. Okay, so that's why it is very important to you watch this numericals till end. First question: a series LCR circuit contains a pure inductor of inductance H. So first thing that you have to do whenever you are reading a numerical question, try to write down whatever variables are given. Okay, so pure inductor is represented by the symbol L, so inductance is 5 Henry. Okay, a capacitor of capacitance is given 20 microfarad. Whenever you are reading, as soon as you read the question, you write down the variables. Okay, this will shorten your answering time. And a resistor of resistance 40 ohm. So resistance is 40 ohm. Okay. If the AC source is, now what is the AC source? AC source is given by 200 volt. Okay, 50 hertz, frequency is 50 hertz. Okay, so these are all, everything is given about the question. You don't need to draw the circuit diagram. If you can draw, fine. Okay, so what is the circuit diagram? Sometimes they give you marks for drawing a circuit diagram. If you are drawing the circuit diagram, then you have to mention the values of individual things in the circuit itself. So 40 ohm, okay, 5 Henry, 20 microfarad, and this is 200 volt, 50 hertz, right? I made a mistake. Can anyone tell me what mistake I made? If you are not sure, this is a AC circuit, so the symbol should be AC, not DC. Okay, that is the mistake I made, right? So this will be the diagram. So if you are drawing this diagram, fine. Sometimes they give you 1 mark for the diagram, but not always, because you can solve this problem even without drawing the diagram. So diagram is not 100% necessary in this case, right? Now let's see what they have asked you. Find the impedance. First step is find the impedance. Okay. Second step is also find the resonant frequency of the circuit. So finding the resonant frequency is very easy. We will teach you after the first part is done. Finding impedance is slightly longer process, but trust me, it is not difficult. Okay. Impedance is given by square root of R square plus XL minus XC whole square. This is the formula for impedance. The thing that you have to do is to calculate XL and XC. Okay, what is XL? XL is omega L. Now omega is not given. We know that omega equals to 2 pi f. Okay, and in most cases you don't need to remember omega L. You need to just remember 2 pi fL. Okay, so this is the formula. This is the inductive reactance. So 2 pi fL. Now what is 2 pi is 2 pi, right? Simple formula. Formula is simple, right? Only thing you have to put the values and calculate the thing. So what is f? F is given 50 hertz. Okay. And one more important thing about these questions is that the pattern of the question is same. Okay, so there will be a voltage with the frequency given, there will be LCR given. Sometimes they might change the pattern, we will see one question also, but it will be given in this format. If you remember this format, that okay, 200 volt 50 hertz, 50 hertz is the frequency, 200 volt is the voltage. Okay, then it will be very easy for you. In fact, in this question we don't even need this value 200 volt. Okay, now what is L? L is given 5 Henry. If it is given in millihenry, then you have to convert it into Henry by multiplying 10 to the power of minus 3, right? So 5 2s are 10, 10 50s are 500, 500 pi. Okay, you can calculate this value, okay, in computer using your calculator. Okay, whatever value it will come, I don't remember it, it will be somewhere in around 1500. Around 1500, I'm just writing the approximate value. Now you have to calculate XC. Okay, it will be somewhere around 1550, somewhere around. Okay, this is approximated value. I don't have the calculator right now with me, so I am not writing the exact value, but I know pi is 3.14. you just multiply it, you will get the value. Now what is XC? Formula for XC, that is capacitive reactance, is similar to XL, but here 2 pi FC, it is 1 by. In case of XL, it is directly 2 pi FL. In case of XC, it is 1 by 2 pi FC. Okay, so don't be confused. Now again you have to put the values, 1 by 2 pi times 50. C is given to 20 microfarad. So microfarad means 10 to the power of minus 6. Okay, this is the only thing that you have to be careful about. Okay, now let's simplify. 5 2s are 100, 50 2s are 100, 100 20s are 2000. So 1 by 2000 pi times 10 to the power of minus 6. So if you see these three zeros, I can cancel with minus 6 as 2 pi times 10 to the power of 3. Okay, 2 pi 10 to the power of 3, and you can calculate 10 to the power of minus 3. Minus 6 was there, I have reduced 3 zeros. So you can write this as 10 to the power 3 divided by 2 pi. Okay, or it will be 500 divided by 2 pi. Okay, you can calculate these values, whatever value it will come. You have calculator. Okay, you can calculate this value, 250 divided by 3.14. It will come out to be 80, around 80. Okay, so it will come out around 80, and I think this is not 550, it will be something less than that. Okay, 540. Okay, now you have to calculate the impedance Z. So we have already calculated, resistance is given, resistance is 40 square. And before coming to this step, what you should do, you should calculate XL minus XC. Okay, XL minus XC you have to calculate. That is one thing. XL minus XC, just calculate it first. So it will be some 1540 minus some 80. You will get it, it will be around 1412. I remember this value, I don't remember the calculator. Don't take the exact values. Okay, you have to use the values. So what I will do, I will write this as 500 pi minus 250 divided by pi. Okay. I made a mistake, sorry. I made a mistake. What mistake I made? This is 10 to the power 3, right? So 1000. 1000 by 2 pi. So 1000 by 2 pi means it will be 500 by pi. So it will be 500 by pi. Okay. So it will be 500 by pi, and the answer will be 1412. And it will be XL minus XC square, so 1412 square, and if you calculate it, it will also come out to be 1412 ohm. The unit is, you have to be careful, everything is in ohm, okay, because reactance has the same unit as resistance. So XL will be ohm, XC will be in ohm, and your impedance will also be in ohm. Now what is the, this is the part 1, answer for part 1. Now what is the answer for part 2? That is resonance frequency. Resonant frequency is given by, this is also a simple formula, 1 by 2 pi square root of LC. Okay, so again 2 pi, put the values only, okay, don't be worried, okay, there is a 10 to the, if you are worried about 10 to the power values, okay, microfarad, millifarad, then you need to practice these problems more, okay, this is nothing to worry about. Now 1 by 2 pi, 5 to the 5 20 is a 100, 100 square root is 10, right? Now 10 to the power of minus 6, square root will be 10 to the power of minus 3, okay. Again you can cancel one of the zeros, so it will, you will write this as 10 square by 2 pi, okay. One of the zero is reduced, then and then that will be 10 to the power of minus 2, it will go up and it will become 10 to the power of 2, right. So it will become 100 divided by 2 pi, so it will be 50 by pi. It will come around 16 hertz, okay, it will come around 16 hertz. So if you see 1412 ohm and 16 hertz, okay, exact values is not required, you can take the approximate value as well, and as you have the calculator, you can use the calculator value and you can get the calculated value as well, okay. They give you plus minus 10%, there is anyway relaxation is there, right. Now question number 2, okay, an AC source of frequency 50 hertz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistance of 100 ohm. So now what are the given things? Inductor of 1 Henry, okay, capacitor of, capacitor is C, capacitor of 90 microfarad. 90 microfarad means, let me write it directly here, okay, and the resistor of 100 ohm, okay. So what does the current leads or lags the voltage? Calculate the phase difference between the current and the voltage. So this is a different type of questions. Pattern is same, if you see pattern is same, frequency is given, voltage is not required, so voltage is not given. So first step is if voltage lags or current lags. So whatever, whenever these values are given, what you have to start? You have to start with finding XC and XL. XC and XL. Okay. Whatever, no matter whatever the question is, this is the pattern. Okay, that's what I was saying, that XC and XL you have to start with. Okay, what is XC? XC, we know that it is 1 by 2 pi FC. Okay, so let's put the values. 1 by 2 pi times F is 50, and most cases frequency will be given 50 only. Okay, in case of competitive exam, because you don't have time, you are not using calculators, they give the values such that it can be cancelled. Okay, but otherwise for normal class exams, because you can use normal calculator, they will give you the values, you have to put the values and calculate it. C is given 90 times 10 to the power of minus 6. Okay, so just simplify this. What will be the value? 10 to the power of 6 divided by 100 pi times 90. Okay, or 1, 2, 3 zeros, 3 zeros will be cancelled. So 10 to the power 3 divided by 9 pi. Okay. So, if you take this value, this 9 to be close to 10, then you can take this to be 100 divided by pi or 100 divided by 3.3. Okay. So, it will be 33, around 33. This is an approximated value. Okay. I am not using calculator, so you can see I am just using an approximated value which is close but not exact. Now, what is XL? XL is easy, 2 pi FL 2 pi 50 times 1. So, it will be 100 pi, that is around 314 ohm. Now, which one is greater? Okay, which one is greater? XC is greater or XL is greater? So, as we can see from these two values, XL is way greater than XC. So, XL dominates XC. So, from here we can say that XL is greater than XC. Okay, now some knowledge you need to know. What knowledge you need to know? If XL is more than XC, that is circuit is inductive. In inductive circuit, okay, current lags. In inductive circuit, current will lag the voltage. Okay. If it is opposite to that of that is XC is greater than XL, then it is a capacitive circuit. In capacitive circuit, current leads. Okay, current leads in capacitive circuit, current lags in inductive circuit. That is the knowledge that you need to know. Nothing difficult. Now, this is the first part. Okay, current leads or lags, current lags here. Now, calculate the phase difference. How can you find the phase difference? To find the phase difference, there is another formula, tan phi equals to XL minus XC divided by R. Now, why I am writing XL minus XC, even though in phase difference it can be XL minus XC or XC minus XL based on who is greater. Here XL is greater, so XL minus XC will be positive. So, we are writing XL minus XC. In another problem, we will see that in that case XC is greater, so XC minus XL will be the formula. This is based on whatever whoever is greater. Okay, whoever is stronger, he has the power to sit first, right? So, someone is stronger, he said, "Hut, I want to sit here," right? So, that is the thing. Now, what is XL? XL is 314. XC is 33, R is 100, okay, it will come around 2 point something, 2.7 I think, okay. So, now you can use your calculator to find phi. If you are not able to find the calculator, you can leave your answer whatever way you are getting, 2.74, that will also be accepted. Okay, this kind of answer will also be accepted, because if you are not using scientific calculator, so you cannot find the value of tan inverse 2.74, right? Normal calculators cannot calculate this value, right? So, the answer will be 2.79. Okay. So, the answer will be current lags and tan inverse 2.79, which is very close to 70 degrees. Okay. So, this is the answer. Because it is not a perfect value, so you cannot calculate it. So, you can leave the answer here, you will get full marks. Okay. Not difficult, not even time consuming. If you know the steps, if you follow the steps one by one, you will get full marks, right? Now, next question. This is an relatively easy question after two little difficult question. This is easy question. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit. This is only RC circuit, in which R is 3 ohms and C is 800 microfarad. Calculate impedance of the circuit and current through the circuit. So, first of all, here what are all given? R resistance is given 3 ohm, okay, capacitance is given 800 microfarad, right? And what else is given? 200 volt, voltage is 200 volt and frequency is 50 Hz, right? So, these are the given values. So, first we have to calculate the impedance. Now, in this case, where is XL? L is missing completely. So, what we will do? We will put XL equals to 0. Okay, either you remember a separate formula for this, or if you remember one mother formula, that is Z impedance equals to square root of R square plus XL minus XC whole square, right? And in this formula what you have to do, you have to put XL equals to 0 because there is no L. L is not there, so L is equal to 0, so XL will be 0. So you get this is nothing but R square plus XC square. Sir, what happened to this negative sign? There is a square, so square of negative will become positive, right? So before asking any question, be careful what you are saying. Okay, so if you put this 0 minus x is whole square minus xc minus minus plus, so only x is whole square. Similar thing you can do for RL circuit as well. For RL circuit, put x equals to 0, it will be R square plus XL square, right? So first thing what you have to do, you have to calculate XC. Now how can we calculate XC? Let's not use too much space. XC is 1 by 2 pi FC. XC equals to FC, right? 1 by 2 pi times F is 50, C is 800 microfarad. So I am writing minus 6 as plus 6 in the denominator directly. So now as you are developing this skill, you can do such kind of things, right? Now what you can do, 10 to the power of 6 divided by 50 to the 100 pi times 800. Now how many zeros are there? 1, 2, 3, 4. So 4 zeros are there. So 4 zeros will be cancelled from the top. So it will be 10 square. 10 square means what? 100 divided by what is left? 8 pi. Okay, so 8 pi is left. Now let's cancel 225. 4 2s are 88 and 4 25s are 100. So it will be 12.5. So and pi is 3 point something, right? So 12.5 divided by 3 point something, it will be equals to very close to 4. So XC will be close to 4 ohm. Okay, so XC will be very close to 4 ohm. Now what you have to do, you have to put the values. R square is 3 square plus 4 square, right? 9 plus 16, 9 plus 16 is 25. So impedance is 5 ohm. So impedance is 5 ohm. Simple, okay? When mathematics is simple in this case. Next is current through the circuit. So we have not calculated current in any of the cases. If they ask you current in any case, RCL circuit, RLC circuit, okay, whatever circuit it is given, LCR circuit, if you calculate the impedance, then current will be V by impedance. It is not V by R, it will be V by impedance, RMS value of the V. V is 200 and impedance is 5. 40 ampere, right? So current will be 40 amperes. Simple. So 5 ohm 40 ampere is the answer, right? Now next question. This is a little tricky question. I will not exactly solve the problem in whole. I will give you the formula and I will give you the idea. You can try and solve the question, and later on if you found the answer, mention that in the comment below. This is the last problem. So if you are wondering, sir, the lecture is already 1 hour over, don't worry, it will be over now. Okay, a resistor of 50 ohm, a pure inductor of 250 millihenry and capacitor. Here if you see, capacitor value is not given. What all are given? Resistor of R 50 ohm, okay, then a pure inductor of 250 millihenry. 250 millihenry means 10 to the power of minus 3. Okay, milli means 10 to the power of minus 3. And the capacitor are in series in a circuit containing an AC source of, even though the volt is not required in this case, voltage 220 volt and 50 hertz. Frequency is always important. Okay, in AC questions frequency is always important. Okay, XL, XC are important. Okay, resistance is secondary here. Okay, it comes only at the final case where you are calculating the impedance. Okay, now what is the question in the circuit? The current leads the voltage by 60 degree. Current leads, very important line, current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So how can we calculate this question? So first step, we already learned that tan phi phase difference is XC minus XL by R. Sir, in the last problem you said XL minus XC. Now you are saying XC minus XL. We are confused. Don't worry. Here it is said current leads. Current leads means XC is greater than XL. If current lags, XL is greater than XC. This is a small concept. This will not only help you here, as we have seen in the fill in the blanks question and MCQ questions. If you remember this concept, there might be a question based on this concept in MCQ and fill in the blanks. So you have to remember it. Okay, current leads in pure inductive circuit, or in case of RLC circuit, current leads when capacitance is more, current lags when inductance is more. Okay, so what you have to do, you have to because we always want positive value, we have to switch it, okay, based on who is greater and who is small. So now phi is 60 degrees, so tan 60. Okay, phase difference angle is given, phase angle is given, so you can directly write tan 60. XC we don't know, okay, capacitance we don't know, XL we know. Okay, XL value you can calculate using the formula 2 pi FL. Okay, whatever value it will be 2 pi FL. I have not. R value is given. Now, what is tan 60? Tan 60 is root 3. So, root 3 equal into R. Now, do the cross multiplication. XC minus 2 pi FL. Okay, or XC equals to root 3R plus 2 pi FL. Okay, now this is not the end. This is not the end. That's why I am not going to solve it. Here, XC is 2 pi FC. Okay, so you have to put this value. You will get some value here. Every values are provided, so you will get some value, say X. Okay, or say a constant value you will get, say A. You will get a value A. Now from here you have to calculate C as 1 by 2 pi FA. Okay, this is the answer. If you solve the numerical, you will get this will be around 20 microfarad. Okay, it will be very close to 20 microfarad. Solve the question and then tell me in the comment below that whether you are able to solve it or not. So we have reached the end of the lecture. I hope you enjoyed the entire session. I know last few section was little boring, but trust me, if you are preparing for your PU board and if you want to score 70-80% in your PU board and your midterm question, then alternating current will be your best friend. Okay, practice these few questions only these 3-4 questions. If you practice, you will be able to answer one numerical problem in your upcoming exam. Okay, I hope that helps. I will be back with ray optics chapter soon, and rest of the chapters are very small. So tell me if you need other chapters in the comment below. I will do only MCQ and small answer type questions from those chapters. Otherwise, I will skip that for now. We will do that when your PU final board exams are near. Okay, so right now I will be back with ray optics chapter, and till then, bye bye.